In the last video, we completed the challenge to fix the guessing game so it used the while loop, but I also finished by saying that we should need 10 guesses or less to guess any number from 1 to 1000, which we've currently had our program set to. So I want to talk about that a bit more. The thing is, trying to guess a number between 1 and 1000 is difficult. The guesser will be wrong 999 times out of 1000. What if we could narrow that range down so we're only guessing a number from 500 numbers? That improves our chances. Now we'd only be wrong 499 times. If we reduce that further to 250 numbers, we'd only be wrong 249 times. So that's how a binary search works. When you have an ordered set of data to search through, you can split the data in half each time. Guessing a number is very much like searching for a value in an ordered set of data. Of course, we know that the value you're guessing does exist. That simplifies things slightly, but the basic steps are the same. So our first guess is 500, which is half of 1000. So if we have to guess lower, we halve 500 and guess 250. For the third guess, we halve 250 and guess 125. Halving 125 gives a floating point value 62.5. Now we're only guessing whole numbers, and we've seen that Python's integer division rounds down. The middle column shows the integer values we'd use instead of the floating point values that we get when dividing by 2. By continuing to halve the range of values that we have to guess, we can guess any number from 1 to 1000 in a maximum of 10 guesses. Now the table only shows 9 guesses. It's showing what happens when we have to guess lower each time to show how the range of values halves with each guess. If the answer was 2, we'd have to have another higher guess after we guessed 1. That would give us 10 guesses, which is the most we'd need in order to guess a number from 1 to 1000. Now we may need fewer guesses, but we shouldn't need more than 10. Of course, sometimes we have to guess higher, not lower, but the principle's the same, and you saw that in the previous video when I started doing binary searches to find the correct answer. When guessing higher, we use the upper half of the range instead of the lower half. Our first guess would still be 500. For the second guess, we'd split the range from 500 to 1000, giving 750. If we had to guess higher again, the third guess allows the range from 750 to 1000 to give 875. With each guess, the range of numbers we have to guess is halved. In reality, we'll use a combination of higher and lower guesses. For example, let's say the answer was 998. After our ninth guess, 999, we'd have to guess lower. The range of numbers to guess is between 997, our 8th guess, and 999. So we'd guess 998 and get it right with the 10th guess. Right, so let's work through a real example. To keep the slides manageable, we're going to be guessing a number between 1 and 10. We should be able to do that within 4 guesses. So let's say that the answer is 7. We start off by guessing the midpoint between the low and high values. The formula we use is low plus, and in parentheses high minus low, integer divide by 2. So putting our low and high values in the formula, we get 1 plus, parentheses 10 minus 1, integer divide by 2, which is 1 plus 4, giving 5. Remember that integer division rounds down, and 9 integer division 2 is 4. So 5 is our first guess. We're told to guess higher. That means the answer must lie somewhere between 6 and 10. We know it's greater than 5, so the lowest it can be is 6. That's our new low value for the range. The midpoint now becomes 6 plus 10 minus 6 in parentheses, integer divide by 2, which is 8. So therefore our next guess will be 8. We're told to guess lower. That means the answer must lie somewhere between 6 and 7. We know the answer is less than 8, so the largest it can be is 7. That's our new high value for the range. The midpoint now becomes 6 plus, parentheses 7 minus 6, integer divide by 2, which is 6. Integer division does round down. So our third guess would be 6. 7 is greater than 6, so we're told to guess higher. Our low value now becomes 7, the same as the high value. At this point, a human would guess 7 right away. The computer has to do the calculation first. The midpoint now becomes 7 plus, and in parentheses 7 minus 7, integer divide by 2, which is 7. So our fourth guess will be 7, and we get the correct answer. So each incorrect guess halves the range of numbers that we have to guess. That's why this technique is known as a binary search or binary chop. The binary search algorithm is the most efficient way of finding an item in an ordered list. It forms the basis for the data structures that database programs such as SQLite and Oracle use for storing the database keys, and that allows for very fast searching of the data. Alright, so in the next video, we'll write the code to guess a number using a binary chop. See you in the next video.